HackerRank. So these problems are based on string. So the first one is super reduced string. So the problem says reduce a string to of lowercase characters in the range of ASCII from A to Z. So what we have to do is we have to reduce the strings. You can read the question, and the example is given here. So the example says the string is AAB, so we have to remove the pair of adjacent letters that match. So here A and A matches, so what we have to do is we have to delete them and we have to keep the B. So AAB will shorten to just B, right? So similarly ABBA, what it will become is, first it will become A, then BB will be removed, so it will become AA. Again that AA will be removed, so it will become nothing but an empty string. So that's the question we have to do. So sample inputs are also given, like A, B, C, D. So out of these three, two of them will go, and these two C will go, and out of these three again two of them will go. So we will be left with A, B and D. Again that's explained over here. So let's jump into the code. So what we can do is, here we have to just write the function here in HackerRank. So we have here defined super reduced string, this function. What we'll do is we can take we are getting the string as an input, right? So what we'll do is we'll make the list of that string. So s is equal to list of s. So now what we can do is we can keep an iterator, so I equal to 0, and we can start a loop. So while I is less than length of s minus 1, because we don't want to go to the end because it will go out of range. Now what we will do is we'll check if the ith element is equal to the I plus 1 element. So if s of I is double equal to s of I plus 1, so in that case what we will do is we will delete s of I colon I plus 2. So why we are doing this slice here is the ith element will be deleted, along with that I plus 1th element will be deleted, I plus 2th element will not be deleted. So that's the reason. And again now what we have to do is, like in this case, when B and B were removed, we had to go back to this A and check if the A had the next combination with the next letter. So in that case what we have to do is we have to go back with the I to that position, so that we can check the values again. So we have to change the value of I also. So what we can do is I is equal to max of I minus 1 comma 0. So this is really important part over here. Why? Because we can do I equal to I minus 1, that is one way of doing this, but in that case I can become negative also. So what if it is an empty string and we are doing I is equal to I minus 1 and it becomes it takes I to a negative value, so that we do not want that. Also what this will do is it will keep that I in positive. So in this case here when I value was 0, 1, 2, so here I value was 2, so it will make it 2 and 2 minus 1 1. It will take out maximum of 2 and 1 and 0, so that will be 1. So it will bring it to that particular index. So that is the reason we are using this change for I. At the end, if that is not the case, what we'll do is else I plus equals 1. We'll increase I by 1 each time in the iteration, that is for the while loop. That's it. So outside the loop what we can do is we can put the result is equal to empty string dot join, and we can join s. So and we can return result result. If there exists a result, it will return that, else it will return empty string. That's it. So we will run the code, and it does pass all the test cases. So this is one way of doing this question. This is brute force method again. This is a brute force method. I'm using loops, and the time complexity here is O of n square. So we can optimize this code by using stacks. So what we can do is, I'll keep this as a comment, and I'll write this again. So I'll show you a better way to do the same question. Define super reduced string is. So let's understand how we can use stacks for the same purpose. Let's say we have this string over here, a b b c c d a d d. Let's say we have this. Now when we are doing this with loops, it will take O of n square n complexity. Why? Because it will have to again iterate many times here. So to optimize the code, we can use stacks here. So how stacks will be helpful is, we'll make an empty stack. Okay, so each time we'll iterate in this loop. What we'll do is, we will put the character in the stack. Okay, so first time we put a in the stack. What a becomes? A becomes top. Okay, next one is b. So is b equal to top? No, let's put b to the stack. B becomes top. Now next is also b. So is b similar to is b equal to the top? Yes. So we will pop from the stack and we will go to next one. Is it? And now top has become a. This is the top. So are they equal? No. So put b back to stack. Again now c will come. So c and b are equal? No. So c will come. But next c is equal. These are equal. So we'll pop this, bring b to stack. Like this we will do. We're using a stack, and end of the day we will get the result. And the good part is, it will have order of n time complexity. That's the reason we optimize the code, and that's how we can optimize this one. So we'll code this one. So we have taken a empty stack over here. So for I in s, for I in the string, what we'll do is if stack and stack of -1 equal to I. In that case, what we'll do is stack.pop. So what we are doing here is, here if stack means we are checking if whether the stack is empty or not. So if stack is empty, it will return false, and if it is not empty, it will check with this condition. If stack of -1, stack of -1 means the very last element, that is the top element. If it is equal to I is what? Character of that string. So if they are equal, what it will do is, it will pop from that. Okay, after popping from that, we will just keep that else part. Else stack dot append I. So if it is not same, what we'll do is, we will add that element to the stack. Now come outside the loop and we'll put the same thing, result equals strings of join and stack, and then we will do same thing, return result else empty string. That's it. So this code will also pass all the test cases as expected, but this is an optimized approach, and this gives O of n complexity, whereas this gives O of n square. So this is a much better approach over here. So thank you. That's it for the video.